Hey everyone, this is Josh with a fun crypto security tutorial for you today. In this video, we're going to be talking about stealing cryptocurrency seed phrases from pictures. Yes, this video is about OCR seed stealing malware. In particular, we're going to talk about very real attacks that have targeted crypto users, the SparkCat malware family. But first, we're going to dive into the underlying coding technologies that make this attack possible. And we're going to show a fun educational demo of this concept that I wrote called OCRSeedSwipe. And of course, we'll wrap up with some handy prevention tips so that you don't become a victim of this malware attack. So first, let's start off by examining the underlying technology that makes this attack possible. The real sophistication of this malware comes in obfuscating this code and allowing it to find its way into seemingly legitimate software. But the actual code to just extract text from an image and check if that text matches the pattern of a seed phrase is remarkably simple. There are two valuable technologies or tools that we can use to conduct this type of attack. The first is called OCR, or optical character recognition. This is a very common technology that allows a computer to extract text from an image file, so that you could later put that text in a document, for example, or have a screen reader read it out. So OCR can fall under two sorts of families. There's rule or algorithm-based OCR, which has actually been around for a long time, and newer AI or artificial intelligence-based OCR. Whatever underlying technology you're using, OCR is all about being able to give a computer an image file and extract text out of that image. So of course, if we want to attack seed phrase pictures, like a screenshot somebody took when they set up their wallet, OCR is the tool for us. Now, the second programming tool that makes this attack possible is what we call a regex, or regular expression. This is a very, very common programming tool used for all sorts of pattern matching applications. What regular expressions allow developers to do is write code that can detect the pattern that we want in a string of text. So regexes are commonly used to check if a string contains a valid email address or phone number, for example. In this case, we can write a regular expression that matches the pattern of a cryptocurrency seed phrase. So let's talk about a fun educational demo showing this concept. And as always, this is open source and available on the Chain Tutorials GitHub. So if you like to code or you want to check out how this works and tinker with your own setup, you can find OCRSeedSwipe. In this case, this Python application uses PyTesseract for OCR, and this is a commonly used rule-based OCR library wrapped in Python for easy use. So we can feed PyTesseract an image and have it extract out the text for us. So once we have our text, the next part of this attack is examining whether or not the text matches the pattern of a cryptocurrency seed phrase. In this case, I'm using a very simple method to generate this regular expression. I'm simply building a regex from the BIP39 word list, which is a 2048 word list of possible phrases that can be put into a crypto seed. So I'm essentially creating a big, dumb sort of regex that looks for 12 to 24 words that all come from this dictionary. It's not the most sophisticated way to look for the pattern of a seed phrase, but it's definitely effective, it definitely works, and it gives us a good approximation when looking at a file or string of text. So in this case, we're just looking for 12 to 24 words out of this dictionary. This particular code does not do full validation if of the seed phrase. And what I mean by full validation is it doesn't actually check that the seed phrase contains the correct checksum, for example. It's just checking for 12 to 24 words that come from this dictionary. Now that won't tell us if there's any balance in this wallet, that won't tell us if it's actually a valid seed, but this is a great starting point if you're an attacker. You can parse through a large volume of text using this, pull out possible seed phrases, and then later write more sophisticated code to actually validate the seed or even see if there's a balance available. If you're a malicious attacker, you can even automate the process of swiping out all funds in that crypto wallet. So this is just my educational demo, but what about the real malware attacks that have happened? Yes, this attack actually has targeted real crypto users, in particular, the SparkCat malware attack. This attack snuck this malicious code into both Android and iOS applications, in apps such as food delivery and chat apps across a global audience. So this code snuck in and of course needed permissions to examine the user's photos and scan photos for the patterns of seed phrases. Security researchers found that this malware looked for certain keywords, and I would assume it was looking for keywords that came out of the BIP39 word list. And like most real malware, this involved a command and control server, so that the attackers could extract seed phrases from users, presumably to clean them out later. So I find this to be a really, really interesting class of malware attack against crypto users. The fact that you can not only scan text documents, but even pictures for the pattern of a seed phrase, and then clean users out, is really scary if you're a defender, and really interesting if you're the attacker. So, of course, we want to know how do we prevent this attack. And there's a really, really simple way to prevent this. Never ever store a cryptocurrency seed phrase on any machine, a phone or PC, in any plain text form. And when I say plain text, that does include images, because in this context, plain text means unencrypted. It does not matter if you store your seed phrase in a .txt file, in a Word document, in a Google Doc, or even as a screenshot from your crypto wallet. If it's not encrypted, code like this can find your seed phrase, send it off to attacker, and clean out your wallet. It's very, very important that we never store crypto seeds unencrypted, period. If you're using a hot wallet where you're already storing the keys in encrypted form on, say, a mobile phone or a PC, it's generally okay to store another encrypted copy of the seed phrase, for example, in a password manager. This does introduce another point of failure, but the overall level of security is about the same, provided you're using a strong passphrase and well-implemented encryption. But better yet, especially if you're using a cold wallet or hardware wallet, is to simply only store the seed in a physical form, such as written down on paper or engraved in metal. This means that no machine can find your seed, and the only way for an attacker to get your seed would be to have physical access to it. For most crypto users, that's generally outside of our threat model, and it's very, very easy to implement as a prevention measure for this type of attack. So, if you found this interesting, there's lots of other malware attacks that are out there. I would like to recommend, if you're looking to protect your crypto, to check out my new book, Digital Sovereignty: Protecting Your Crypto Assets Against Common Threats. This book dives into malware attacks against crypto users, and it's available in paperback, ebook, and you can read the individual chapters for free online on GitHub. Because like all Chaintute's work, the book is open source. So as always, I hope you found this tutorial interesting and informative. Keep your crypto keys safe, and thanks for learning something new with me today.